everyone. Welcome to Stats Rescue 911. My name is Lynn, and in this tutorial, I'm going to show you how to run and interpret a one-way independent ANOVA, also known as a one-way between subjects ANOVA. And we're also going to look at how to run post hoc tests on this ANOVA, should it be significant. Now, before we get started, there are a few things that you should really know before, following the tutorial, or at least these things would be very helpful to know, and that is the difference between versus within subjects factors, how to enter factors, which is just another name for independent variables, how to enter dependent variables, what post hoc tests are and why they're used, and why error bars and confidence intervals. Now, it's not like this video will be completely useless to you if you don't know and understand these topics, but it certainly would make it less painful. Now, if you don't know these topics, look for some of my other videos, and hopefully these are already there. If not, then they should be coming soon. All right, so let me introduce you to the study that we're going to be analyzing data from that will put the analysis into context. So my students and I, years ago, we did a survey on our campus where we administered it's basically a fear survey. We asked people a number of questions. One of those questions was, to what extent do you love, like, or hate horror movies? So they had to identify themselves as either loving them, liking them, or hating them. All right. So this is why the analysis is going to be independent or between subjects. And it's because if a participant taking this survey, I shouldn't say if, when a person took this survey, they identified themselves as belonging to just one group. So either they love horror movies, they like them, or they hate them. So the participants in this group are not the same people as in this group or this group. So that makes the factor between subjects. Now, if you are trying to analyze data where the people in this group are the same as this group and the next group, then this is not a one-way independent ANOVA. You're looking at the wrong test. All right, so ask yourself, do I have one independent variable with 3 or more levels? Here I have 3. And verify that you have a different group of people in each level. And I will add one more thing. These participants, so the ones in the first group, second and third, they have not been paired or matched. All right. And if you don't understand what pairing or matching is, then chances are they haven't been. So you're good to go. All right. So with that introduction, let's go to our actual data set. And let me bring that up. Here we go. So in this data set, we need to find the horror movie variable. So I've got to move this over. Okay, here we go. So here is the horror movie variable, whether people love, like, or hated them. And you can see that these participants have been categorized. They've been coded according to their responses. And what we are going to do in this analysis is we're going to look and see whether this variable, horror movie attitude, had any effect on overall fear score. So participants were asked to rate how much fear they typically experience when they are in various situations. So, for example, in their home during the daytime, or driving during the daytime versus nighttime driving or being home at night. Now, there were other questions, but you get the gist of it. And then we looked at their total fear score. So this was just an average of their fear in different situations. All right, so now we want to know, does attitude towards horror movies have any effect on fear scores? So we're going to go to Analyze, And then we're going to go down to general linear model. Now you can run a one-way independent by going here to compare means, but you won't get as much information as you will if you go to general linear model. So this is where I recommend you go. And then we're going to go to univariate. And that's because we have just one dependent variable that we're looking at. So click on that, and this has already been loaded up for you, but I'm going to reset it so that way you can see how it's done from scratch. So the dependent variable we said was fear score. So we need to find that in our variable list, and here it is at the very bottom. So we're going to move that over to where it says dependent variable. Now, this is where you will likely put your independent variable, where it says fixed factor. A factor, remember, is just another name for an independent variable. A factor is fixed if the specific levels were chosen by the experimenter for a reason. In other words, they weren't levels chosen at random. If they were levels chosen at random, then you would choose random factor. But in most cases, in psychology and behavioral science, we don't randomly select levels. We decide what levels we want to test for our factor, so they're fixed factors. So our factor was, in this case, horror, which was the horror movie attitude, so you need to move that over. And then we go here to various options. And the first one that you probably will be interested in is this, and it's plots. That's going to give us a graph so we can see the mean for horror, the different horror categories. So we're going to move that over to the x-axis, horizontal axis. And SPSS already knows that we're going to be plotting fear on the y-axis, so we don't have to do anything there. But we do have to hit add, because if we don't hit add, we aren't going to get a graph at all. Now, you have to choose between a line graph and a bar chart. I recommend, well, I guess it's personal preference, but I like the bar chart for a graph like this. And I'm going to also ask it to include the Y error bars. And here you have a choice between using standard error of the mean for each group, so love, like, and hate, or you could use the confidence interval for each of those groups. And I'm going to choose the confidence interval. So I'm going to set it to 95%. That means that 95 times out of 100, the true mean for whichever group you're looking at, the true mean mu was likely captured in the interval. So now I'm going to hit continue. And the next place I'm going to go is post hoc. Now, remember that with a one-way independent ANOVA, if it's significant, all you know at this point is that there is a difference somewhere among your means, but you don't know where that difference is. And so you're going to need to follow up with post hoc tests, and these will tell you where the difference is exactly. All right. Now, we don't know if our ANOVA is going to be significant at this point, but we're going to line up those post hoc tests anyways, just in case. So we take our independent variable, which is horror, and we move it over here to where it says post hoc tests. And then the three that I like to recommend are LSD, Tukey, and Scheffe. Now, there are others you can choose from, but these are very common in psychology and behavioral sciences. And so I'm betting that you probably won't want to run these other ones. All right. Okay, now we hit continue. And the next place we want to go is where it says options. And the ones that you're most likely going to want to use and need are descriptive statistics, estimates of effect size, and homogeneity tests. There are other options here, and so you might want to consider them depending on the needs of your analysis. But again, for most analyses, these are sufficient. Now we hit continue, and now comes the exciting part. Hit OK. And here are the results. So this first box is just good to look at, just to verify that you ran what you thought you ran. So this is a one-way between subjects factor. And again, that means that different people are tested in each group, and there's been no pairing or matching. And this is the independent variable with the levels that you looked at, and that's in this case love, like, and hate. And we notice that the sample sizes are not equal, but they're pretty good. They're pretty close. This next box represents the descriptive statistics. So we can see the mean fear levels for each of our 3 groups, the standard deviation for those groups, and once again, sample size. It's a little annoying that SPSS does not give us standard error of the mean or the actual confidence intervals, but that can be obtained fairly easily by going up to Analyze. And again, if you wanted those statistics, you would go to Descriptive Statistics and then Explore. All right? And then you would just move your fear variable. I know we're digressing a little, but it might be important to get that information. You would move fear over to the dependent list, and you want it broken down by the different categories of horror. So you move that over to here. All right, so here's your dependent variable, here's horror. And then when to get the confidence intervals, you go to statistics and you ask for the confidence interval. And it will, in the descriptives, you'll also get the SEMs, the standard error of the mean. So you can change this to whatever you want. All right, so that's just good to have. I'm going to cancel out though, so that we can return here. Maybe this is all you want, is the mean, standard deviation, and sample size. All right, the next box, this is an important one. This is the Levine's test for homogeneity of variance. All right, and what it's doing is it's testing an assumption of the one-way independent ANOVA, and the assumption states that the variance for each group will be statistically equal. So for love, like, and hate, the variances will be statistically equal. So to see if we have satisfied that assumption, we're going to look here where it says fear, and then this needs to go away. We're going to look at fear based on mean. Now, this is the actual F value for the Levine's test, but really what we want to look at is this over here, the Sig value, also called the P value. Many resources, many books and everything call this the P value. And if it's less than 0.05, it's significant. And normally we're happy when we get significant results, but not here. We never want any test of assumptions to be significant. And this is telling us that our Levine's test is significant, so this is actually not good news. All right, and so we now have to deal with it. We've got a violation to the assumption, and I'm going to show you how to handle that in just a few minutes. Right, and again, it's because the Sig value was less than 0.05. The next box over here, this is the actual Anova Results. And where you're going to look is over here where it says horror. This is the factor that you're testing. And you're going to move over here. In all likelihood, you're going to need to report the degrees of freedom associated with the test, so with horror. And there's actually going to be 2 numbers you're going to look for. This first one are the degrees of freedom associated with the factor you're testing, but you also need to report the degrees of freedom associated with the error term. And so in this analysis, it was 55. So the 2 numbers that you're going to report are 2 and 55. It's always maybe helpful reminder to know that the smaller degrees of freedom are always going to be reported first. The degrees of freedom for your factor are always going to be smaller than for the error term. All right, the next place we're going to go is we're going to look at the actual F value. This is the one that is testing the effect of horror on fear. So we probably will want to report that. And then this is the Sig value, or also called, remember, the P value. And in order for this F to be significant, so in order for our test to be significant, the sig value has to be less than 0.05, and it certainly is. Now, remember though that up here we had a violation, right? So when we looked at Levine's test, we discovered that we don't have homogeneity of variance, we have a violation. So going down here to your sig value, the SPSS does not automatically give us a correction if we have a violation in HOV, homogeneity of variance violation, not for this test. So what we have to do, or what I recommend you do, is voluntarily make it a little more difficult for you to find a significant effect down here. All right. So instead of, normally you would say, well, it's significant if it's less than 0.05. This time, because you want to make it a little more difficult, say that you will only say that something is significant if the sig value is less than 0.01. Well, even if we adopt that more strict criteria for significance, this is still less than 0.01. So we're good. All right, no worries. We have a violation, but even with the voluntary correction, we still have a significant effect. Now, you'll also probably want to look at this value here. This is partial eta squared. It's a measure of effect size. So what this is telling us is how strongly the IV influences or affects the DV. In this case, how much influence horror movie attitude had on fear scores. And the higher the value here, the greater the influence, the greater the effect size. And I can tell you 0.523, that is huge. All right, so in this particular study, we found a huge influence of horror movie category. So whether you love, like, or hate horror movies, we found a huge influence of that on fear scores, self-reported fear scores. All right, but at this point, we still don't know. We know our ANOVA is significant. We know the effect is very, very large. But what we don't know is which mean is different from which. Is love different from like? Is like different from hate? We don't know. So for that, we have to go to our post hoc tests. Now, if the ANOVA was not significant, you would not look at these. Because remember, post hoc tests are telling us which means are different. If your ANOVA was not significant, that tells you your means are not different. So why would you go on to look at this? I don't know. So don't do it. But because our ANOVA was significant, we can now look at the post hoc tests. All right, looking at these post hoc tests, remember that we asked SPSS to run 3, Tukey, Scheffe, and LSD. How these get interpreted is the same. All right, so I'm going to show you how to interpret the Tukey test, but the way you interpret it is going to be the same for Scheffe and LSD-T. It's missing the T. That's funny, SPSS. Okay, so let's look at Tukey first. We want to know if the mean for love is significantly different from the mean for hate. So what you're going to do is you are going to look at these two means along this row, right? Love versus like, and you just read across until you get to this sig value. And the sig value is less than 0.05, so that tells us that these means are significantly different from each other. We don't know, unless we go back up, we don't know which mean is higher or lower, but we got that information when we went when we looked at one of the very first boxes up in the output. We saw what the mean for love and like was, so we can just go up there and look to see which one was higher and lower. You can also look at the graph because we remember that we asked SPSS for a graph. All right, the next thing you want to do is move this box. Here we go. We want to we want to compare love and hate. So we're going to have to move along the diagonal here, and then we look across the row till we get to the sig value, and we see that that is not significantly different. The sig value is greater than 0.05. So there is no difference between love and hate. Now, what about like and hate? Because we've done love versus like, love versus hate, but not like versus hate. There's that annoying box again. We'll deal with it. Like versus hate. So we go over and we look at the Sig value here for that row, and we see that this comparison is significant. So those two means are significantly different. All right, now that's how you would figure out which means are different from which, and you would do it for the Tukey, Scheffe, and LSD-T. Students ask me, well, which one should I report? And the answer is, it depends. Of course, it depends. I would start with Scheffe. Look at Scheffe. This test has the lowest risk of making a type 1 error. And that's always good. But unfortunately, it's also the least powerful, which means there is a greater chance with Scheffe that you're going to miss real treatment effects. But with that said, I would still look and see, does it give you the pattern of results that you were hoping for? Because maybe it did pick up the treatment effects. And if it does, then report using Scheffe, because it carries, again, the lowest risk of a type 1 error. But what if Scheffe does not give you what you're looking for? Then the next test I'd look at is Tukey. Tukey is more powerful than Scheffe, so you're more likely to find those significant effects, and those effects are more likely to be real treatment effects. However, the problem is that even though the Tukey test has more power, it also has an elevated risk of a type 1 error compared to Scheffe. So it may be the case that, yes, you're more likely to detect the treatment effects when they exist, but you're also going to be picking up other stuff, potentially some false positives. So there's always going to be a trade-off. But I would look at Tukey and see, does it give us the pattern we want? And if it does, then report this one. Now, if, let's say, Tukey does not give you what you're looking for, then you can move down here to LSD-T. And this one is the most powerful test, so you are going to detect the most significant differences relative to the other tests in most cases, but you also have the highest risk of making a type 1 error. So I would only report using LSD-T if you could not get what you were looking for with these either tests above. All right. Okay, in this particular case, it doesn't matter because both tests, I see the exact same pattern of results. All right, so there's a difference between love and like, between like and hate, but not between love and hate. And that pattern is the same for all three tests. So I would report using Scheffe. All right, now if we look over here, here are the means for each group, but let me point out, these are not truly the mean for love, like, and hate as far as their fear scores. These are estimated marginal means. And estimated marginal means will not be accurate unless the groups were the same sample size. So if I had 20 in each group, we could look here. But because we have different people in each group, don't use these means. Remember that at the very beginning of the output, we got the means for each group. We got their standard deviations. We did not get their confidence intervals or standard error of the means, but I showed you how to do that. So but this is, looking here, this is good enough for seeing, well, which mean was higher than the other mean. We already know, based on the post hoc tests, which mean is different from which, so we can just look at the pattern here. It's just that I wouldn't use the actual values that you get from this particular table. All right, so what we have found through the use of post hoc tests is that both people who love horror movies and hate horror movies report elevated fear. All right, it seems that if you only just kind of like horror movies, that's associated with the lowest fear values. All right. So when you report the results of the analysis, make sure that you don't just say that there was a significant effect of poor attitude category on self-reported fear scores, you have to tell people who reported the highest fear and who reported the lowest fear. So that's true no matter what factor you're analyzing. When you get a significant effect, always tell people not just that it was significant, but who scored highest and who scored lowest. All right, I hope you found this video useful. If you did, don't forget to like it and check out some of my other videos. All right, see ya.